Hi, everyone. Thank you for joining us in this webinar where we will showcase some of the best practices of machine learning model observability, from deployment through real-time drift analysis and immediate anomaly detection, all the way to unparalleled retraining strategy and insight based on production, performance, and observability. Do note that this webinar will be recorded and available in our resource center in Superwise website. Also, I urge you to share your thoughts and questions in the chat here below, and we will do our best to address them all during this session. Cool. So I'm Amir Servi, head of product at Superwise, father of two. I love technology and football. I'm a fan of Real Madrid and Liverpool, so you can only guess that I had an interesting week. But let's dive right in. In today's session, I will demonstrate some of the industry's best practices when it comes to machine learning model observability, using a fraud detection model which data was taken from Kaggle. This, of course, can be implied on any model, machine learning model. So when we're done here, you will be able to imply the same exact flow on your own model in our machine learning model observability platform. Simply sign up to our community edition in our website and get going. Before we start, just a word about Superwise, founded in 2019. Some will say the pre-MLOps era. Superwise is the leading provider of machine learning model observability and monitoring platform, enabling data scientists, machine learning engineers, and machine learning based organizations to improve their AI in production at scale. But let's start with a simple alignment. Model monitoring is hard, and let's try to understand why is that. We see three main challenges on the tech level, operational level, and organizational level. Eventually, machine learning researchers focus on exploratory data analysis, model development, and experimentation. These members might not be as experienced software engineers who can build production class services, not talking about many data types, metrics, customization. We know it's endless. On the operational side, there's the infrastructure gap. Machine learning system can require you to develop a multi-step pipeline. We will see it in order to automatically retrain and deploy model. And many of these tools are new, not unlike the traditional software development, needs to be integrated and managed. The question is, who is responsible for which part of the model or the pipeline? And as we saw the growth in DevOps roles, we see the same in machine learning with MLOps. In addition, in the organizational level, there are multiple stakeholders for these models, and multiple stakeholders who are looking to surface incidents as soon as possible, be it data scientists, machine learning engineers, of course, product managers, or even business units. I myself heard of quite a few practitioners who got a request to retrain a model from a sales representative. So, and this is, by the way, only when we're talking about monitoring 1, 2, 5 models in production. But at scale, it's even harder. If we were talking about 1, 5 models, think about what happens when you have tens or hundreds of models like some of our customers have. Tens of segments, hundreds of features, and 5 metrics is, is these 5. Usually you have tens of metrics. In this case that they showed right here, we're talking about 50,000 data points a minute to monitor. So you can only think what happens when you grow, and you want this process to be easy. It shouldn't be as hard. Another challenge that does not apply specifically to the scale issue is how to determine or how to express what is an anomaly, what is a violation of an expected behavior, what is the expected behavior of a model. So it's easy to see it when you compare it to a traditional software monitoring. So in software monitoring, there's the functionality. When user does this, this should happen. It's all deterministic. You know what should happen and what shouldn't. And if something that shouldn't happen happened, you know that you need to fix. For example, 80% CPU is bad, and then you need to scale up. Scale up means just to replicate the service. But when we're moving to model monitoring, machine learning, we're talking about a stochastic world. It's not deterministic. And you're no longer monitor functionality, you monitor quality. And it's hard to define when quality is high enough or not. For example, let's say you calculate drift metric, and you calculate it using a KL divergence equation, and the KL drift is 2.34 for a specific metric. Is that good? Is that bad? If it grows to 3, is it an anomaly now, or is it within the boundaries? Eventually, AI is experimental by nature. That's about it. So yes, model machine learning is great, but as one man once said, model monitoring is expensive, but it costs more not to. And when I say expensive, I'm not talking about money. I'm talking about efforts, team and organizational efforts in order to fix something that is not monitored is high. And if you're not monitoring, it will cost you not only the efforts, it will cost you also money. But I think it's time to show how we can take a model from production, integrate it to Superwise, and get value within 10 minutes of time. You can start the clock right now. We will show how we integrate a model from production to Superwise, start logging in production data. Then we will analyze this model behavior and automate the analysis using pre-configured policies and anomaly detector. Eventually, we'd want to get some insights to find the best retraining strategy and optimize our production performance. Cool. So let's start. Second, I'm moving to the platform. Cool. So this is our observability platform where all the integrated production models and their versions are listed for you to have some kind of a bird's eye view of your production pipeline health status. In this project that you will see right here, currently, of course, we have one model, as you can see. And this is the model that we will show today. I have preloaded it and ran monitoring on it, so we will see the results and not have to wait for them to arrive. But let's start by integrating the same exact model, and I will show step by step how easy it is to do that. We will start by, of course, adding a model entity. Click here. Let's name the model. Perfect. We can also add tags. If it will help us to manage the pipeline in case we have a lot of models. Let's put these two. We can also add new ones. Description, and that's it. We're done. So here it is. Here's the model. Now we would like to start sending data. we want to configure its first version. So we will simply click here. As you can see, we have several actions that we can do: add a version, log production data, create segments, and add monitoring policies. We'll start by adding a version. Click on upload a file, because I will show you this version created from the UI at the moment, and then I will quickly show you how it's done using the SDK. Let's start by naming the version. Then we can simply either use example data if it's your first time and you don't know what to look for, or look at the documentation. But I will click here to, let's choose the relevant baseline data set. Open. Now it's uploading. We will see in a second how such data should look like. And the next step, great. So the data looks like that. On the first row is the entity names. And then below it is all the values, just a simple table. Superwise has added this row right here. That what this row means is that Superwise automatically inference each data type. And we tell you this in order for you to be able to verify and edit in case you want. If something is not numeric but categorical, you can change it. And it's important in order for you to get the right metrics and analysis to go over and approve. Let's confirm. That's it. We're done with confirming that. And now we are moving to defining roles. So Superwise assume that each column in the table is a feature. You only need to indicate the ID of each prediction. In our case, it's the transaction ID. As you can see, all the entities are here, or all the relevant entities, and the timestamp, so we will know to put it on a timeline. So in our case, it's transaction date time. That's it. We can go and create version. But if we want to get the full value of Superwise of our observability and monitoring also on the performance level, predictions labels, we need to define those as well. So prediction value is fraud, prediction probability, probability is right here. In case you have it, again, it's optional. Label and metadata in case you have that. Clicking on creating version, what happens in the background is that all the analysis is being made in the background, and in a second we will have the ability to run analysis on this model. Great, we have it ready. So clicking on that model, I will be able to see data analysis of the baseline that we just uploaded. But let's move to the next part of sending production data, and then we will start analyzing both baseline and production. So I'm clicking on log inference data. Again, I can run code for SDK and automation, or upload a file. I click on upload a file, see how easy it is. If I had multiple versions, I had to choose which version I want to update with production data. In our case, it's the only one. Click to browse and choose production data. This is a 100 megabyte file, so I won't expect it to I won't expect it to end soon. So I will have another replica of our platform, and until it will be ready, we will see right here. Meanwhile, let's start with a demo preloaded model in order for us to start analyzing it. So again, we started with baseline. Once we get here, we see all the baseline, the model's baseline entities, their expected behavior, what are the expected values, what are the roles according to what we've defined. Type, of course, we can also look at it according to its feature importance. You can see that the most important feature is transaction amount, of course, and understand their distribution, be it on a graph plot or a table or bars. Not only that, we can also see the same on the production data. We simply set the time frame that we want to analyze, and the same exact analysis can be found right here on the production data. But the most amazing part is the ability to compare and see how different entities have drifted from production to baseline. In our case, we currently see April this year versus the baseline. Again, it's the same exact data, just with comparing between two different data. So in this case, let's see the differences in the, you know what, let's try to sort first according to which entity drifted the most. And we see that the most drifted feature is terminal 30 days transaction amount. We can simply click here to try and understand what's under the hood. We can see that baseline in blue shows a different distribution that we see in production. Again, this can be seen in different methods and can be shared with your team members. Great. But this screen gives you a static image. We all know that when scaling up, nothing worth looking at without context. What if we wanted to analyze metrics over these entities and see their behavior over time, with time as the x-axis? So great question I asked there. The answer underlies in the trend screen. The trend screen is where you can select the time frame that you want to analyze, be it here or here on the predictions graph. The segment you want to analyze, whether it's the entire set or maybe only mobile users, web users, or any subpopulation that you want to define. We will see it soon. You can also select multiple segments and compare between those. And of course, select metrics to see. In our case, I pre-chose input drift, distribution shift of this feature or another. You can also do it for predictions values. Also performance, the false class, which is, I think, the most important class when you're talking about performance of fraud detection model. That's it. You can simply choose any metrics and it will appear here. Not only that, you can select the metrics you want and save any view from here, and then you will be able to see it right here. Cool. So once when we're looking at the metrics, we can see that again we're looking almost on a half year. It's quite hard to understand what's happening here, what's normal, what's not. I do see here an anomaly. You know what? I see different behavior here. I don't know whether it's an anomaly, whether it's a violation. Is this within the normal boundaries, or is this a violation? So I cannot tell from here. I can go and have a zoom in to better analyze this period by either seeing its distribution or comparing it to a baseline if we know that everything was okay, or compared to a different time frame where we know that everything was okay. Let's do this right here. I compare the distribution of this time frame to this time frame, and we'll be able to see some differences in data. Let's see it right here. You can see the differences right here. I'm not sure it's an anomaly at the moment. I do know that there's something happened. And this is missing values, by the way. It means that this feature, there were 9% missing values, where usually it's less than 1%. I also see that here there's in the input drift, let's move it up. we see that there's a clear seasonality. And if we look at the dates, we also see that the peaks are weekends and the lows are weekdays. So there's a clear seasonality. I also see that here on the 23rd of March, there was some kind of a bump here. Again, I don't know if it's a violation, if it's over the normality boundaries or not. I can again investigate, but I found these anomalies with my eyes. I can see that something happened here mid-March, but I won't lie, I'll be honest. I knew this gonna appear here before showing it to you. And one might wonder, how would you find it if you didn't know in advance? Or even ask, is this an anomaly, as mentioned? Is it out of the boundaries? So first, we can, as showed you, we can mark it and start analyzing what's under the hood and compare it to a better time frame. But the bigger answer would be automatic monitoring policies. Let's click right here. And we split the monitoring policies into two. We'll hit here to see it, but there are pre-configured policies and there are custom policies. So what we get here, for scale and simple configuration processes, we have collected all the best practices for when monitoring and machine learning model, and created this generic library of templates that altogether will guard your model from misbehaving in production without you knowing about it. For example, let's click on dataset shift and see what's under the hood. First, we can see immediately the main policy capabilities. The dataset shift template comes preset with all the relevant metrics and features we want to monitor. In our case, we're talking about all features in all segments, and it runs on a daily basis. It's 4 p.m. We can see some more information here, and also add notification channels, which is a key element when monitoring. And it means when something happens, where do you want us to let you know? In our case, we didn't set anything at the moment, so let's quickly add a new one. There's email, webhook, if you want to, I don't know, generate a specific process to run once a policy finds an anomaly. It could also be a retraining process, or Slack, or one of these PagerDuty, New Relic, Datadog platforms. Let's quickly add my email, Amir's email. Perfect. Hope I got it right. Great. Every time there's an anomaly, I will get an email to my inbox. We can use it as is, or we can click edit. Let's zoom in by clicking edit and let you understand how easy it is to express what you want to find. So the first thing is conditions. Let's click on edit to see how it's being chosen. First thing, we chose input drift, because this is what we want to search for, input drift. Then the threshold, you can set manual thresholds if you want. But I think, and we know for a fact, that it's too hard to understand what is the threshold for input drift of 100 features. And there's the automatic threshold configuration that allows you to base the expected values on the history. And you can also state where do you want Superwise to learn from, whether it's all the history of the data or starting from a specific date. Let's say starting of this year, something changed, and you want to learn data only from this date. Also, there's the direction. Do I want to know when boundaries are broke from both sides. In our case, I want to know when drift is too high. I don't care if it's too low. And sensitivity, whether it's low, medium, or high, let's set it to medium. We can always change it in the future. That's it. We can set a minimal incident length, meaning how long do we want the incident to run in order for us to get notified. We want to run this on the entire set or all segments or specific segments. When do you want this to run and where do you want to get notification? Let's create the policy and data set shift drift. Perfect. Okay. Now, as you can see, other than this policy, I've already created these pre-configured several templates on this demo model. Now we'll just have to wait for an anomaly to happen and we will get notified. Also here, I've created this in advance in order for us not to have to wait for anomaly to arrive. So we can simply go into the incident screen and you can see that nothing is open because we're talking about past data. Everything is enclosed because everything is already back to normal. So let's go and understand what we see here. On the left side, it's some kind of, let's say, inbox of incidents. We can see here that the policy that is called feature missing values found an incident. If we'll open up the time frame, we will see that this is exactly the same one that we saw in the trend screen, the missing value anomaly. And we also see that we thought we found something, but there's a lot more to it. We see that this missing values anomaly happened in 3 different entities. Say terminal 30 days span, terminal 1 day span, and terminal 7 days span. Again, here we can mark and compare to baseline to different time frame or see distribution just to get to understand what's under the hood. But one important thing that we see here is, and it's very important when you select a tool for monitoring your models in production, we know to aggregate several violations and anomalies into one incident, meaning one alert for all these 3. And if we go to the second input drift, we see that there's a drift that was found. We thought we saw this bump, but it happened in another place. So again, 2 anomalies, 1 alert. Think what could have happened if we had 100 models with 50 policies. You need the ability to reduce noise, but also not miss anything. So that's the trade-off. And that's about it. Now, what do we do with this incidents? The next step in the flow is, if I click here, is to build a retraining strategy. Let's enter this notebook to understand what we're looking at. So I won't go over this all flow. There's a lot of code here, which is very clear. I will just quickly go over the output of such flow. So first of all, we want to understand data DNA insights. Maybe we have several groups that we can split the model into. As we could see in the trend screen, there's a clear difference between weekdays and weekends, and this is exactly what we see here. According to the dates, we see that there is the color changes according to the drift between the dates. So there is a clear drift between weekdays and weekends. And if we'll go here, we can see that there are 3 groups. The orange group that looks the same to each other, this is weekends. The green group is weekdays, and the red here is another group, specifically in dates that
we had a lot of anomalies. We might want to exclude these red dates from retraining, and maybe we want to split the model into two models, one that will be served in weekdays and the other one in weekends. This brings me to this step. If I'll go here, I will see that these are the dates with anomalies. Again, we want to base our retraining on data. And this is the data that we want to know before retraining. We don't want to push data that is anomalized to our retraining data set. Next, most drifted features, very important. This is, for example, an output. You can see that is weekend transaction has drifted a lot, and it's important that we will use this specific feature in our retraining session with more data that is more like in production. Last is most drifted segments. We want to see whether a segment has drifted too much or got a lot bigger, because if we will see that a specific segment is very big and behaves differently than other segments, we might want to retrain a specific model for that segment. That's it. Two things that I want to show. First of all, we're done here. Two things that I want to show that I didn't show is that when adding a version, again, we show the upload file, how simple it is for scaling up. And if you want it to be part of your CI/CD, everything can be done through the SDK. Of course, you start with installing the SDK and initializing it in your pipeline. You can simply generate a token, and it's right here, copy and paste. Then upload baseline data, just like we did here. Upload the baseline data. It could be a data set, a training set, test set, or a specific time frame from production. Then configure the schema, which, as we did in the UI, just let Superwise know which column is the ID, timestamp, prediction values, and labels. Name the version, and you're ready to go. Activate your version, and that's it. Second thing I wanted to show is segments. Again, these are pre-configured segments that I've added in advance, but creating a segment is as easy as giving it a name. Let's say high amount transactions, and I'm looking for transaction amount that is above, let's say, I see these are the expected values, so $500. That's it. I created the segment, and now we'll know to analyze this segment by itself. Great. Back to our presentation. Great. As you could see, we are monitoring the entire machine learning process, and you gain visibility over the whole pipeline, be it raw inputs, features, model, predictions, and actuals, of course, performance. And when I said that this is the missing piece, so here it is. You can see all the pipeline. Its output eventually is a model, and you put that model in your serving tool, and then you have the monitoring and observability. But when do you retrain, or when do you fix any part of this pipeline, and what do you focus on? This is the missing part in the puzzle. Cool. We're right before the end here. So key takeaways. What should you take away from this webinar? So when you're looking for a tool, and I more than recommend you to find a tool and do it when you are planning to scale up, and not when you're talking about 2 models. Find a tool that is pipeline agnostic. We saw the pipeline, we know that it consists of many tools, and you want to be able to integrate it all to one pipeline that every part can talk with each other and support every framework and tool. Build for scale, you want to find a solution that is API driven and allows you for full automation of the full process, from connecting a version, logging in data from production, logging labels, set up monitors, and set up segments. With the ability to be as generalized as possible, you also want the ability to be as customized as possible. Each use case at each company requires different metrics on different entities. Not only different metrics, but also different customized policies, integration, and workflows. So this is a key. And enterprise grade, even if you're not an enterprise, you do want your data to stay safe, and you do want, again, to be able to scale up when required. Cool. No, I think we're done here. So I want to say thank you all for joining us to this webinar. Again, I welcome you to sign up to our community edition, and when you sign up, you immediately get the ability to set up an onboarding session either with me or one of our machine learning monitoring expert. You are more than welcome to check our documentation and quick start that explains everything I just showed here today. You're more than welcome. And of course, if your organization might enjoy such tool, you are more than welcome to schedule a demo either with me or our support team and talk to us at any time, any point, and we will help you to gain full observability over your machine learning pipeline. Great. So thank you so much, guys, and see you next time. Bye-bye.